In this tutorial, we will look at the tools in the Documentation tab of the RhinoLands interface. And we will see how to work on the layouts in preparation for printing the project. The first group gathers different visual markers. With the zoning tool, we define a hatch with a specific color or pattern to highlight or document different areas of the project. To do this, we first need to click on an interior point of the area, and the closed curves that will define the zone will be automatically detected. In this dialog, we can select if we want to add a label with the name for this zone, which I will name as pavement. We also have settings for justification, typography, and text scale. We check this box if we want to include the area calculation. And we also select if we want to mark the zone with a hatch or not. If we activate it, we select a hatch pattern. And also its color, its rotation, and its scale, in the same way we have seen in the previous dialogues. In this first tab, we are defining the visibility of the zone in 2D. By clicking on the Material tab, we choose the texture that will be used as the material for the zone in 3D mode. Using the Explore button, we choose an image from the library or any that we have saved on our computer. Once we validate the configuration, we need to make one last click, which will define the insertion point for the label with the name. If we prefer, we can also select the zones by selecting edges, changing this option in the command bar. In this case, we manually select the curves that delimit a zone. Once selected, we press Enter or right-click to see the zone insertion dialog. I rename this new zone as Playground and will select a solid pattern. In this way, we document or represent the different areas using hatch patterns and different textures. If we select an already created zone, we can edit its parameters at any time from the editing panel. I can edit aspects of the hatch or remove the labels visible in the drawing. With the Level Mark tool, we insert level marks to indicate the elevation at a point in the drawing. From the front view or elevations, we see how as we move, the level mark on a z-axis changes the indicated elevation value. It can also be placed in plan view. I activate the 3D view to get the correct elevation and switch to shaded mode. In this way, I can mark the elevation at each of the landings of the staircase. In the editing panel, we have different shape options, such as circular, triangular, or cross-shaped. We also configure the size, color, and style. And wherever we click, this elevation marker will be added. The Slope tool draws an annotation leader with associated text that shows us the slope between the starting and ending point of this leader. At the moment of insertion, we can also adjust this guideline to the elevation of the terrain surface to measure its slope. For this element, we can configure the size, arrow style, and starting point. The Dimension command allows us to dimension plans, civil elements, and other entities from a specific coordinate origin point on the plane. I activate the planting layer and will set the plants represented with the layout plan symbol. Now, using the Dimension tool, we first select a point that will be set as the coordinate origin for the next dimensioning, for example, this corner. Then, we select linear dimension or ordinate dimension and choose the plant elements we want to provide with coordinates to indicate their planting point. When we finish, they are automatically dimensioned, indicating the distances from the point we have defined as the origin. To edit these dimensions, we don't do it from the editing panel. Instead, we can select them all at once from their layer, and in the Properties panel, an Ordinate Dimensions tab is enabled. From this tab, we change the text size and settings that we will see later, along with other types of dimensions. For now, I remove the coordinates we just created and return to the representation of the 2D crowns, to see the last tool in this group. The plant shadows generate shading under each vegetation specimen to improve the graphic representation or indicate the direction of the projected shadow. This shape, which in some cases we see as circular and in others conical, depends on the crown shape indicated in the database. For this shading, a separate layer is also created, which is useful for activating or deactivating the shading, or to select the entire set of shadows and edit them from the editing panel. In this panel, we can direct the shadows. If I switch to the rendered view mode, I see the shadow of the wall, according to the current sun parameters and position for the document. I can copy this direction for the shadows and also edit the height of the sun, as well as set the shading pattern to use. The color will be taken from its layer or from the color specified in the General tab. The tool group below gathers all the insertion tools for listings. As you can see, we have listings associated with various types of lands elements, as well as listings for plants, blocks, hardscape elements, zones, and sprinklers. And we also list the terrain operations with volume calculation of earth in each of the operations performed. I am going to insert a couple of them to see how to edit them, as they all work the same way. To add a listing to the drawing, we only need to select which type of listing to document and click on the drawing to define the insertion point. Once inserted, we can move or scale them like any other element in the drawing. When we select any listing, we have a series of tabs for its parameters, which are common to all listings. The General tab, from which we modify the name of the listing, the Table tab, from which we adjust if we want to add a title or headers, their color, text size, and alignment of the different elements. From the Border tab, we select which borders we want to add to this table. First, we indicate the horizontal divisions, and then if we also want vertical lines or an outer border. In the Filter tab, we adjust which of the elements of this type are listed. By default, all elements will be listed, in this case, urban furniture from the drawing, unless we select the by layer checkbox, which will only list the urban furniture elements from the selected layer, or by region, which will only list the objects contained within a selected boundary. If we have a larger project and only want to list the furniture from a specific region, we draw a boundary using any closed curve shape and select it using the Add Boundary button. Once we have a boundary, we could extract objects within this region if we select another closed curve contained within the first one using the Add Hole button, or also clear the boundary selection. Additionally, in this tab, we indicate whether we want to list those objects that are on deactivated layers or objects that are hidden in the drawing view. The last tab will change for each of the selected listings. For each type of listing, we find different fields. The checkboxes that are activated or that we activate will be the fields shown in the list. For urban furniture, we can add an icon and configure its size, display an index number or activate the supplier field, among others. To add custom fields, we open the Options dialog. In the Document Properties, we look for parameters and click on Add. We give a name to the new field, such as price, material, or any field you want to add. We indicate what type of value will be entered, such as text or numeric value. If we select one of the lists again, we can now incorporate this new parameter as an additional column in the list. To add the value of this field for each of the elements, we will select each element from the Selection panel, and in the Properties panel, under the Parameters tab, we fill in the box corresponding to each field with its information, such as the brand name or the product price. When we update the table, it will be updated with this information. By selecting one or more lists, we can copy the style settings from another, using the option Copy Properties from another list, and customize the fields to list for each type of list. In the plant lists, we can indicate the initials of the species or specific name, among other fields. And in the zoning list, we can also activate the display of the corresponding shading. Before continuing, I will reposition them, align them to the right. Any of the lists inserted in the drawing can be exported using the Export List button. In the top drop-down menu, we select which list to export and save it on our device as an XLS spreadsheet, HTML, or we can preview the HTML. The next group of tools we find are the labeling tools. The first is plant photo. The first thing we need to do is select a plant in the drawing. Once we have it selected, we press enter or right-click the mouse, and it offers us a selection of photographs related to the species. If we have the Cloud Images box checked, we need an internet connection. If we deactivate it, we will only see images that we have on our device. If we select an image and click Browse, it takes us to the folder where the images are located, and we could add new images saved with the species name. Once we select a suggested image, we position it in the drawing space. We make a first click to position it and a second to size it. A leader is created between the plant and the image. We have the option to deactivate it, just like the border or text, and adjust the size of the visible text or the photograph. When we select a forest element that combines several species, we first select and position the image of the first species. And upon completion, it will prompt us to select the image of the second species. We repeat the process successively with the different plants in the drawing. Other labels we have available are the plant labels. This adds a label for the plants we select. And we configure whether we want to display the label with the initials of the species, name, or index number. We also indicate the shape of the label, the order, and whether we want a border and its shape, in addition to the text style. If we select a row of plants or a forest, it counts the total number of specimens it contains. The next labeling tool serves the same function as the previous one, with the difference that we can link several specimens of the same species. And it will establish a connecting line between them. Since I have established the labels with the index of the list, I enable this value for the plant list as well to be able to see the reference. The last label is a custom text label. It allows creating labels with custom text or annotations. To improve the organization of the project, I create a new layer called Documentation where I will place the lists and labels. For a quick selection, we can select elements of the same type using their icon in the Selection tab. To add more types of elements to the selection, we hold down the Alt key on the keyboard. In this way, we will better control the visibility of this group of elements. Before continuing with the rest of the tools, let's see how we usually prepare the documents that we can print. Although we can print views directly from the viewport, we commonly work in what we call layouts. In these, we create designs for printing in a space representative of the paper sheet. To create a new layout, we do it from the plus symbol next to the view names, or directly from its icon in the Documentation tab. We need to define a name for this page, initial detail numbers, and print size. When we accept, we see this gray space corresponding to the page size. The outline we see inside the sheet corresponds to the detail. The details show a view of the model. If we double-click inside, we activate the detail window. These viewports are like another view. The changes we make to the geometry, as well as any element we insert, move, or create, will apply to the entire model and, therefore, to the rest of the views. To deactivate the detail window, we select the layout again from the drop-down or double-click. To control the drawing scale, we reactivate the detail view or select from the outline. And from the Properties panel, we see the equivalence between millimeters on the page and meters in the model. Editing this value to 0.2 meters in the model would be equivalent to a 1 to 200 scale. When working with layouts, it is advisable not to activate the View Synchronization checkbox to avoid deleting or overwriting a previous configuration in the details. If we want to insert a title block in the layout, one thing you can do is have a document where you have previously drawn your title block, with the measurements prepared for a sheet size, and you create a block with it to then import it into the rest of the projects. To do this, we click on Insert Block, and instead of choosing a block from this document, we open the File Explorer and select the document that only contains the drawing of the title block and open it. Since the coordinate point of the title block drawing matches the lower left corner, I click on this corner and it is placed centered on the page. To better see the composition and respect the space of the title block, I rearrange the elements by moving the position of the plant images, avoiding zoom movements to not alter the scale of the detail. In the title block, we only import the text that will not change in the different layouts. For the rest of the texts, we add them using the text tool. In this box, we can write a custom text. Or using the text field button, we can select different functions to automatically obtain data. For example, if I click on Detail Scale, we click on Select Detail and, once selected, we indicate the format in which we want to display the scale and accept. We edit the text style, as well as its height. And once we validate, we click on a point on the page to define the insertion point of the created text. I make a copy of this and select a different function, this time to detect the model units. I make a third copy, and in this last case, we choose a format for the date. To edit a text parameter at another time, we can double-click on it or access its parameters in the Text tab from the Properties panel. And we set the color from the Object Properties. Just like in the rest of the windows, we can choose whether to display it in 2D or 3D, and in which display mode we want this detail. If I set the view to rendered mode, even if it's in 2D, it only converts those lens elements to 2D. However, the surfaces we have, which are native Rhino geometry, will not be converted to 2D. In this case, we can hide them so they don't show in this detail and allow the shading we've created with the zoning tool to be visible. To control the visibility of some elements in the layout details, we have several options. The first option is to hide a layer only in the detail. For this, we activate the Detail view and go to the Layers panel. Since all solids and surfaces are in the modeling layer, instead of clicking the first light bulb, which would hide the layer throughout the entire model, we press this second light bulb to hide the layer only in the active detail. In this way, we can view the shadings and zones again. The second option is to hide one or several selected objects from a detail. To demonstrate this, I am going to create a new layout with a detail of the rear view. I will show this detail in 3D and in rendered mode. To avoid having the lists and those documentation elements visible in a 3D view, I hide the documentation layer only in this detail, as we have seen. If in this case I want to hide this wall, which obstructs the visibility of the rest of the project elements, we activate the Detail view, type in the command bar Hide in Detail, and then select the objects we want to hide and finish. To display these objects again, we activate the Detail view and type in the command bar Show in Detail. We return to the Perspective view to see the Section tool. With this tool, we define a plane that cuts the model. If I want to section the model in this direction, the most practical way is to generate the plane from an elevation. I am going to temporarily hide the layer, Documentation and Shadows. To achieve better program performance, work as much as possible in wireframe or shaded mode. And with those representations of the plans that are less heavy so it goes faster. When we have created this plane, through the section, this object will appear, which is the clipping plane. This indicates where the section is made. It can be rotated or moved. And the arrows at the ends indicate the direction. What remains ahead of the arrows will be the visible part in the section. In the Properties panel, we see in which views it is active. To see the section in perspective or in the desired view, we check its corresponding box. We also have a button to reverse the direction of the cut. To obtain this section in detail, I return to the corresponding page. The size of the details can be adjusted by moving from the control points of the frame of the same detail. And with the new Detail tool, we can create more than one detail on the same page. We draw a rectangle from corner to define the position and size of the new Detail window. In this one, I will choose a right view in conceptual visualization mode and center it. Now we select the clipping plane and I will look for this detail in the layouts. An orange circle indicates that the detail is active. So we check its box to visualize the section in this detail. If we don't want the clipping plane symbol to be shown, it can be scaled, reduced, or moved to the side without affecting the section. We could even hide it. When we create sections, we can assign section attributes by object or by layer. To assign section attributes to an element, we select them. For example, I select the terrain, and from the Properties panel, in the Section Attributes tab, we choose a custom style. We can configure the appearance of an edge by setting the line type, width, and color, and also configure a different print color or width. We select a hatch by choosing a pattern and configuring its rotation, scale, and color. There are also options for controlling transparency or background color. In this way, we assign different section attributes and line widths to various materials. We can also create section attributes by layer to give the same attributes to all elements within the same layer. In the stairs layer, both the different stairs and the ramp element are grouped. So from this layer tab, where section styles are indicated, we double-click and configure the same parameters we've seen from this floating dialog. To adjust print colors or line width in other views or for those elements we are not sectioning, in addition to section attributes, we can also configure colors or line widths for printing. I return to the first layout. Remember that we had deactivated the layer, Documentation and Shadows. When printing, we see that there are several options to define the color. The first one uses the color specified in the Print Color field. The second is Display Color. This uses the same color that we see in the work view. And the third converts all colors to grayscale. When working with RhinoLands, it is advised to always print using the display color. This is because we work with several elements that behave like blocks, such as plants or hatchings. If we configure the 2D crowns, with different colors for each of the species, this information is lost if we use the print color option. Now let's see how to set up colors and line widths, considering this. To set line widths by layer, we go to the Layers panel. There, where it indicates print width, we can customize the width for each layer. For example, if I select the Limiters layer, which contains the walls, I can change the color of all the objects in the layer using the layer color and adjust their line widths. The color that appears next to it corresponds to the print color, but since we won't be using this option, we're only interested in the layer color. If we want to assign a different color to a specific object, we select that object and assign it a custom color from the Properties panel. This color will override the generic properties of the layer. If we set a custom print width in the Print Width field of this same panel, this value will override the width set by layer, following the same logic we have seen. To print the layouts, we position ourselves on the desired page and press the Print button. The first step is to select the printer and paper size. It is recommended to first save in Rhino PDF format. We choose between vector or raster output, which will save the print as a bitmap. For greater fidelity with the on-screen view, use the raster output. And for output color, we choose display color. Additionally, we can indicate if we want the PDF to open automatically upon saving. We choose the destination and name of the PDF file, and upon completion, they will open automatically to show the print. Finally, in our plans, we can also add annotations. To annotate, we activate the Detail view. Using linear dimensioning, even if the selected points are not aligned, it will always draw horizontal or vertical dimension lines, depending on the direction we give it. However, using aligned dimensioning, it draws the dimension lines while maintaining the alignment between the selected points. I am going to perform a linear dimension again. To annotate, we select the starting point and the end point. We direct the dimension with the cursor and make a third click with the right button to fix the position. Once we have created the dimension, by selecting it, we can access and edit it from the Properties panel under the Dimension tab. In this panel, we can edit the text size, the font, where we position the numerical value in relation to the dimension line, arrow style, and size options, among other parameters. The recommended approach to avoid editing each dimension of the drawing independently is to create an annotation style. As we can see at the top, we can select from the default styles or edit them. By using the Edit option, the document options open up, and we can edit the settings of an existing style, or select annotation styles and create a new custom one. First, we give it a name and copy the properties from one of the suggested styles. We mark the annotation style we have created to set it as the document's annotation style, and then we edit it. In units, we can choose to use the model's units or another unit of measurement and the number of decimals we want to display in the numerical value. When we review all the settings, we apply the changes and accept. When we select a dimension, we can create continuous dimensions by clicking on this option in the command bar. And it will create successive dimensions on the same dimension line, as we indicate additional points in the drawing. In addition to linear dimensions, we have the angle dimension. By selecting two lines in the drawing, we can position the dimension to measure the interior angle between them or the exterior. And with the radial dimension tool, we indicate the radius of those curved lines or circles in the drawing. The distance tool is not an annotation tool, but a measurement tool. When we want to know the measurement of a distance in the drawing, without needing to create a dimension, we make 2 points in the drawing and the command bar indicates the distance between the 2 points made. The leader tool generates a leader with the path we give it by generating points, with a custom text annotation associated. The last one in this group is the arrow tool, which adds an arrowhead at the end of a selected line. With this, we conclude the review of the tools and documentation with which you can control the documentation and printing of the projects. In the last video of this tutorial series, we will look at materials and rendering settings to extract realistic images from our projects.